Here's a probability situation. Say you have a class and they're going to take 2 votes on 2 different issues. Now, basically it's, would you rather be the class ambassador, that's the person who welcomes people into the class, or would you rather be the person who carries the flag when the school burns down? Okay, so that's that. Would you rather do one or the other? And then the other vote is, say the class does all their homework and every single student in the class does their homework for 2 weeks. On a Friday, you get to have a fun Friday, if that happens. Would you rather have a chess tournament, or would you rather learn how to solve the Rubik's Cube, which your teacher could teach you? So, which one would you rather do? 2 different votes. And then we're going to say, well, if you pick a person at random, what's the probability that they voted each way in each different vote? Anyway, that sounds confusing, but let's set up a table, right? 2-way, actually it's like an area model. Let me do that, and I'll show you what it looks like. So you might be saying, hey, wait a minute. These percentages, these probabilities, don't add up to 1. It's not 100%. And you would be right. So, turns out that some of the students decided to vote for neither of those things. So we better put that in there. Okay, let me do that. So there we have the other probabilities, the stuff that's left over. People that voted for chess, people that voted for the Rubik's Cube, and the rest. These 3 have to add up to 1. 0.62, 0.12, 26, 0.26. So, now let's fill in the other probabilities in these empty squares, and I think you know how to do that, but I'll fill them in anyway. So here you have it. You can find out all kinds of different probabilities. For instance, what's the probability that you voted to take the flag out and play chess? 0.273, about 25%, a little bit more. What's the probability that you wanted to solve the Rubik's Cube and be the ambassador? Both things. Okay, those are the things that you chose. Well, there's only a 0.05% chance that if you pick somebody from the class at random, that's the 2 things that they voted for. What if you want to figure out what's the probability that they voted for neither one of the votes? They didn't want to do either one of those things, and they didn't want to do either one of those things. They just want to sit in the corner and stare at a wall. Well, doing neither is 0.044, which is a little bit less than the Rubik's Cube and the ambassador, so that's pretty good. Okay, that's for this and that, okay? Those 2 things. We could ask a lot of different questions about that. But what about, say, what's the probability that you want to take the flag out, or you wanted to play chess? Okay, now that's a little bit different. Or means this one or that one, okay? So this is how this works, and that's what we're going to cover tomorrow. So we want to figure out the probability that you pick somebody at random from the class and that they voted for either to play chess or they wanted to be the person who carries a flag out during a fire drill. So, now if we add these 2 percentages, if you notice, they add up to be over 100%. Well, the reason for that is that you have some people that voted for chess, some people that voted for the flag, but you also had some people that voted for both, and they would be double counted in that group. So the way we fix that is we say, let's figure out the probability that they voted for the flag, probability that they voted to play chess, and we're going to subtract the probability that they might have voted for both, and that's going to fix that. And then we're going to figure out exactly what's the probability that they voted for either one or the other one, but not both. Okay, so let's write that down. And there it is. The probability that you voted for playing chess, the probability that you want to be the flag person, minus the probability that maybe you voted for both. And that is right here. That's the total. Either or, but not both. Okay, there you go.